Okay, just to review from yesterday's lesson, do these four problems independently and then we'll tackle limits. Okay, so you can pause the video. Okay, let's take a look at number 1. Can I factor out a GCF on the top and bottom? Well, on the top, I can factor out 2, 10, 48. I can factor out a 2. So let's factor out a 2 and we will get x squared plus 5x minus 24. And then on the bottom, can I take something out from 8 and 64? Yes, I can factor out an 8, leaving me with x plus, well, 8 times 8 is Nintendo 64. Are we done factoring? Not quite. In fact, I know I can simplify 2/8 to become 1/4, so I'm just going to show my work. Well, I'm going to call this 2. I'm going to call this 4 times 2 times x plus 8. And I got to factor this part right here. This x squared plus 5x minus 24 needs to get factored. Well, what two numbers multiply to negative 24 and add to 5? Specifically positive 5. So it has to be a positive times a negative, where the positive number is overwhelmingly stronger. So that combination has to be 8 and negative 3. X plus 8 times x minus 3. I'm going to cancel out where I see fit. So I see a 2 canceling out with a 2. And x plus 8 cancels out with x plus 8. So the final answer is going, the final simplified form rather, is x minus 3 over 4. Okay. Moving on to problem number 2. I look at the top. X cubed minus x squared minus 42x. Can I factor a number out? Nothing besides 1, but notice that all three terms have a variable x. So the GCF is in fact x. So let's factor out x, leaving me with x squared minus x minus 42. All that over, well, now let's take a look at the bottom. Can I factor a number out of 2, 20, and 42? Yes. And another thing to note is they have x cubed, x squared, and x. So not only am I going to take out a 2, but I'm going to factor out 2x as well. So now let's factor out 2x from all three terms. 2x times x squared is 2x cubed. So then 2x times what is negative 20x squared? Well, 2 times 10, well, so that'd be negative 10, and x times x is x squared. So 2x times negative 10x is negative 20x squared. Now, 2x times what is 42x? 2 times 21 is 42, so 2x times positive 21 is 42x. Now, can I factor some more? Oh yeah, I can definitely factor some more. So I notice I've got an x on the top and an x on the bottom. I'm going to get to that later. So for now, I'm going to call this x over 2 times x. I'm going to break that apart. I'll get to that. So now, what two numbers multiply to negative 42 and add to this imaginary negative 1? Well, it has to be a positive-negative combination where the negative is a little bit stronger. So let's go over the terms. We will get x minus 7, x plus 6. Okay? What two numbers multiply to positive 21 and add to negative 10? They have to be a negative-negative combination. Specifically, x minus 7 times x minus 3. And now, let's cancel out some similarities. X over x cancels out to form 1. X minus 7 cancels out with x minus 7 to form 1. So now I'm left with x plus 6 over 2 times the quantity of x minus 3. I'm okay with it left like this because I like factored out. I like it because it makes it easy to plug in. Although you could make this x plus 6 over 2 times, 2x minus 6. So x plus 6 over 2x minus 6. I would prefer it factored out because it makes life so much easier for limits. All right, let's take a look at number 3. Can I take something out from all 3 terms on the top? Not quite. But I do know that I do need to factor this quadratic trinomial. What 2 numbers multiply to negative 80 and add to 2? Has to be a positive negative combination where the positive is a little bit stronger. In particular, x plus 10 over x minus 8. Okay, and now let's take a look at the bottom. Can I take something out from all 3 of these terms? Well, I can definitely factor out a 2, and notice that x cubed, x squared, and x all have a variable of x in common, so I'm actually going to factor out 2x. 2x factored out forms, 2x times what is 2x cubed? That would be x squared. 2x times what is negative 24x squared? That would be negative 12x. And finally, 2x times what is 64x? Well, 2 times 32 is 64, and we already have an x, so we don't need to multiply by another x. But now we need to factor out that quadratic trinomial. So we leave the top as x plus 10, x minus 8. I'm going to put parentheses right there. Please put parentheses. Okay? So now I'm going to look at the bottom. I've got 2x. What 2 numbers multiply to positive 32 but add to negative 12? Has to be a negative negative combination, in particular x minus 4 times x minus 8. Let's look for something that we can cancel out. Well, that x minus 8 has got to go. So now we've got x plus 10 over 2x times x minus 4. Therefore, that is our simplified form, and it actually makes my life a lot easier to leave it like that. Okay, let's take a look at number 4. If I take out all 3 terms on the top, I can factor out a 3, and I get x squared minus 13x plus 30. 2 numbers that multiply to negative 70 and add to negative 3, that has to be a positive negative combination, in particular strong negative. X minus 10, x plus 7. Yes, that's right, negative 10 times 7 is negative 70, negative 10 plus 7 is negative 3. But now I got to factor out this part, x squared minus 13x plus 30. So now, what 2 numbers multiply to positive 30 and add to negative 13? Well, that has to be a negative negative combination. 3 times x, so it has to be a negative negative combination, so that has to be negative 10, negative 3. X minus 10, x minus 3. So we've got x minus 10 times x plus 7. Let's look for something that can cancel out. Oh yeah, that x minus 10 has got to go. So the final answer, we're out of space, so I'm going to put it right there. 3 times x minus 3 over x plus 7. Okay, that take up a lot of time? 9 minutes, not too bad. All right, any questions on this? Well, see, I'm so used to teaching a class, I just went, any questions, and I'm talking to myself because I miss you guys. Sad face. Okay, moving on. What is a limit? Okay, that's the next topic. Okay. What is a limit? So, once again, I'm going to use that analogy. I used to annoy my older brother because I was a little brother and I required so much attention. But I used to play this game called I'm Not Touching You because he used to get bothered when he'd get poked. But if I didn't poke him, I'm not touching him. And yet he was still annoyed. It has nothing to do with actually being touched, but more so with the intent behind it. The intent was to bother him. And if you intend to bother somebody, chances are you're probably bothering them. So let's take a look at the full definition of a limit. So as x approaches a certain value, y approaches a certain value too, right? So we're talking decimals. We're talking, let's say you want to get closer and closer to x equals 3. Well, you want to get close to x equals 3, so let's go 2.9, 2.99, 2.999, 2.99999, or from the other side, 3.1, 3.01, 3.001, 3.001. So we're getting arbitrarily close to a particular value. So a limit, as x approaches a certain value, a limit is where does y want to go? So a limit is where y approaches. So a lot of people get confused because there is no y in the problem. It's where it wants to map out. So for instance, let's take a simple version like the limit as x approaches 3 for 7x minus 2. Now, let's be real. If I wanted to approach x equals 3, right, I could play this game. I could do a little thought bubble. I could say, hey, let's plug in 2.9 minus, so x equals 2.9. So I get my calculator, 7 times 2.9, I got a big old yawn. That'd be 20.3 minus 2, or 18.3. Okay, well I can't actually touch x equals 3, so why don't I try 3.1? So let me try the other way. So let me try my other thought. Let me try x equals 3.1 minus 2. Well, 7 times 3.1 is 21.7 minus 2, that would be 19.7. Okay? Well, that doesn't really help me. What if I get closer? You see what I mean? I can do 2.99, I can do 2.999, 3.01, 3.001. So, what's the problem with actually plugging it in? Truth be told, I don't see a problem with plugging it in. Let's do that. So let's try 7 times 3 minus 2. So I'm going to plug in x equals 3 into this problem. 7 times 3 is 21, minus 2 is 19. So let's just cut right to the chase. As x gets closer and closer to 3 from the left side and to the right side, the closer I get to 2.99999 or 3.00001, y wants to go to 19. And because direct substitution works, that point is continuous. The limit exists and the point exists, and the point equals the limit. So therefore, it is a continuous point. Okay, so let's move on to some other examples. Okay, number 2. Okay, let's go with the limit as x approaches 2 x approaches 2 for x squared plus 5 over x squared minus 3. Well, x squared plus 5 over x squared minus 3. The one thing I want to look for, is it illegal to plug in x equals 2? Well, couldn't hurt to try. So you guys get the idea that I could plug in 1.9, 1.99, 1.99999, or 2.1, 2.01, 2.0001. But the fact is, you never know until you try. Let's plug in x equals 2. So we go blank squared plus 5 over blank squared minus 3. So this becomes 2 squared plus 5, or 4 plus 5. 2 squared minus 3, or 4 minus 3. 4 plus 5 is 9. 4 minus 3 is 1. Let me make that a little bit clearer. 9 over 1 is 9. Hey, you know, you never know until you try that the limit as x approaches 2 is in fact giving us a continuous point. X equals 2 is legal to be plugged in. Okay? See if you can do these problems independently. Let me erase the board. Okay. Do these problems independently. Okay. Now, let me make that a little bit clearer. Right. So the limit as x approaches 3. So as x gets closer and closer to 3, well, where does y want to go? We could plug in 2.9, 2.99, 2.999, 2.9999, 3.1, 3.01. You know what? Doesn't hurt to try. Let's plug in x equals 3. So 3 squared minus 9. Well, 3 squared is 9 itself. And 9 minus 9 is 0. So as x gets closer and closer to 3, y gets closer and closer to 0. You never know until you try. Let's go with x, the limit as x approaches 2 of x plus 1 over x minus 1. Same old song and dance. Let's approach x equals 2 from the left and the right side. Or, you know what? Never know until you try. 2 plus 1 over 2 minus 1. So that'd be 3 over 1. 3 over 1 is 3. As x gets closer and closer and closer to 2, y gets closer and closer and closer to 3. Now, why did I teach rational expressions getting simplified? Well, because I'm going to throw you a curveball. So one of the problems that we ended up with yesterday went a little something like this. Okay. Number 5. The limit as x approaches 3, we like 3 I guess, of x squared minus 8x plus 15 over x squared minus 9. So I'm going to pull out my thought bubble, and we are going to let me correct that date. Sorry about that. Today is actually Thursday. Sorry, I'm actually video recording all these in one day for the first week. I just want to get ahead of the game, so I made a mistake. I recorded the Tuesday and it is the Thursday one, so I apologize. Anyway, So the idea behind this is, okay, so if I plug in x equals 3, right, I'm going to get 3 squared minus 8 times 3 plus 15 over 3 squared minus 9. So if I got 3 squared minus 8 times 3 over plus 15 over 3 squared minus 9, I'm going to get, well, let's plug them in. 3 squared is 9. 9, okay, negative 8 times 3 would be negative 24 plus 15. And I'm going to get 3 squared, which is 9, minus 9. 9 minus 24 is negative 15. And negative 15 plus 15 is going to be 0. 9 minus 9 is 0, and I'm not happy because Isaac Newton says 0 over 0 is what's called an indeterminate form. If I have 2 divided by 2, that should be 1. If I have negative 8 divided by negative 8, that should be 1. And so what's frustrating to Isaac Newton is, why can't 0 over 0 be 1? Well, you do a lot of number theory, it turns out 0 divided by 0 is the only division problem with an unlimited amount of solutions. So we got to get creative. I can't plug in x equals 3 and go, well, the answer is 0 over 0. What does that mean? So I need to factor this quadratic trinomial on the top and bottom. So let's do the limit as x approaches 3 for x squared minus 8x plus 15. If you go back, you know how to factor this. You should get x minus 3 times x plus 5. X minus 5. And now the bottom is x plus 3, x minus 3. Is there anything that cancels out? Yeah, that x minus 3 over x minus 3 should cancel out. Well, there's your problem. There's the reason why x equals 3 equals 0, 0 over 0, because you got 3 minus 3 over 3 minus 3. Once I cancel out that 0 over 0, I can figure out where the hole in the graph is. So limit as x approaches 3 for x minus 5 over x plus 3. I'm going to get a better black marker because this one is slowly fading away. Okay. All right. So now, is it legal for me to plug in x equals 3? Yes. So I'm going to do that now. By the way, you have to keep writing lim as x approaches 3 until you actually plug it in legally. So you've got the limit as x approaches 3 for x minus 5 over x plus 3. Let's plug in 3 now, and hopefully there is no problem. 3 minus 5 is negative 2. 3 plus 3 is 6. Negative 2 over 6 can be reduced to negative 1/3. As x gets closer and closer and closer to 3, y gets closer and closer and closer to negative 1/3. See if you can do this next problem independently. Limit as x approaches 0 for x cubed minus 4x over 2x squared plus 3x. Okay. So I'm going to do my same old song and dance right here, except I'm going to do my thought bubble because I like showing off my brain. 0 cubed minus 4 times 0 over 2x x squared plus 3x, but I'm going to plug in x equals 0. You can see where this is going to go. If I plug in x equals 0, that'd be 0 cubed minus 4 times 0, or 0 on the top, 2 times 0 squared plus 3 times 0, 0 on the bottom. 0 over 0, Isaac Newton has a fit. This is called an indeterminate form. So therefore, I have to get creative and factor out. So let's factor the top. Do we have a GCF? Yeah, x. So that'd be x times x squared minus 4 over, do we have a GCF? Yeah, just an x. 2x plus 3. Right? Oh, there's your problem. That x cancels out with the x. That was your 0 over 0 all along. So now we've got the limit as x approaches 0 for x squared minus 4 over 2x plus 3. Now, I guess I could factor the top and make it x plus 2, x minus 2, but do you guys really see a purpose? I can actually plug in x equals 0. So let's go 0 squared minus 4 over 2 times 0 plus 3. When I plug in x equals 0 legally, I get 0 squared, which is 0, minus 4, 0 minus 4 is negative 4. 2 times 0 plus 3, so that's 0 plus 3, which is 3. I'm just going to clean that up and make that negative 4 thirds. So as x gets closer and closer and closer to 0, y gets closer and closer and closer to negative 4 thirds, but that point is a hole. It can only intend to go there by going closer and closer to 0, like 0.1, 0.01, 0.0001, or negative 0.1, negative 0.01, negative 0.001. But alas, no. We'll see you on Friday to do more limit problems.